take a look at example 1. In example 1, we're assuming that y is defined implicitly by this equation. When you guys look at this equation, do you know what kind of object this is? Just out of curiosity. This guy's a circle. The center is 0, 0, and the radius is equal to 4. It's not important to solve the question, but it's nice when you can recognize that. So what we're going to do, we're going to write our equation, then we're going to take the derivative of both sides with respect to x. So we're going to have x squared plus y squared is equal to 16. When I take the derivative of this first term, that's going to be 2x. That's the easy part. Do you guys know what rule I need to take the derivative of this second piece? Does anybody have any feeling? For this piece right here, we need the chain rule. The outside function is something squared, or x squared. The inside function, outside, is x squared. The inside function is y. Okay. So when we take the derivative of the outside, what are we going to get? We're going to get 2 times something. We got to keep the inside thing. The inside thing is y, and then we multiply by the derivative of the inside. Now the derivative of y is just dy dx. So that's the hard part of this question. And then the derivative of the right-hand side, 16 is a constant, so the derivative of the right-hand side is 0. Does that make sense? So I tried explaining this in the video right here. Oh my God, I just realized I made a mistake in my video. There's no square there. I give up. I was trying to move this box so that I could erase this guy. I guess I'll just scratch it out. So we're using the chain rule for anytime you see a y squared, anything involving y, you got to use the appropriate differentiation rule here. So now we've differentiated both sides with respect to y, with respect to x, sorry. Now we want to keep everything involving dy dx on the left side, move everything else to the right side. So this is going to be 2y times dy dx minus 2x. Okay. Then we only have one term with dy dx here, so we're going to leave that there. We want to isolate the dy dx. So we got to divide both sides by 2y. So when I do that, 1 over 2y and 1 over 2y, then I'm going to get dy dx all by itself, and that's equal to negative 2x over 2y. We can simplify that to be negative x over y, and this is our derivative. So you'll notice that our derivative has both x and y in there. That's fine. Remember, in my earlier example, when I was trying to explain this, when we're differentiating these implicitly defined things, sometimes you have to supply the y value as well as the x value in order to specify which point you're talking about. Does that make sense?